In this video, we look at the standard normal distribution and some probability calculation examples using the graphics calculator. So let's look at the problem. The heights of students in a school is normally distributed. And then there are three parts to the question here. We'll look at each part in turn. So the first part says, find the probability that a student in the school is taller than one standard deviation above the mean. Now, it doesn't seem like much information here, but we realise that every normal distribution can be standardised, so we can think of this as a standard normal distribution with a mean of 0, mu equals 0, and a standard deviation sigma of 1. So now we'll draw a diagram to illustrate the situation. Here it is, mean of 0, standard deviation here where the curve changes shape of 1, and we're after the students who are taller than one standard deviation above the mean. In other words, with a z-score greater than 1. So that's the area that's been shaded there. So we need to know what is the probability of a z-score greater than 1. So using our graphics calculator for this, we need to make sure we're in statistics mode. We go to distribution, D-I-S-T. It's a normal distribution, N-O-R-M, and NCD. It's a variable. We're not using a list which is in our calculator, so we should click on that one. It's already set as that anyway. And now we need to put in the lower bound, the upper bound, the standard deviation, and the mean. Now the lower bound here, for Z, we're focusing on the Z-score, is 1. The upper bound, well, it's the highest Z-score that we can have. We usually put in here the number E to the 99, the highest number that the calculator can handle. Now, we're dealing with this as a standard normal distribution, so the standard deviation is 1, and the mean, mu, is 0. Enter all that information. Now if we hit XE, we'll find that probability. The probability of a z-score of greater than 1 is this. So using our graphics calculator, we found the probability of z greater than 1 is 0.159, rounded off to 3 significant figures. So the probability that a student in the school is taller than one standard deviation above the mean is 0.159. Second part of the question, find the percentage of students between 1 and 2 standard deviations below the mean. Again, we're dealing with this as a standard normal distribution, so the mean is 0, standard deviation is 1. We draw a picture. Here's 1 standard deviation below the mean, 2 standard deviations below the mean. So the area shaded is between 1 and 2 standard deviations below the mean. So we're after the probability of a z-score between -2 and -1. So using our graphics calculator, we go back, and now we put in the lower bound of -2, upper bound this time of -1, same standard deviation, same mean, XE, and there it is, the probability is 0.1359, rounded off, it's 0.136. This one said find the percentage of students, so the percentage of students will be 13.6. Percentage of students between 1 and 2 standard deviations below the mean is 13.6%. Third part, if there were 1,200 students in the school, how many would be less than 2 standard deviations below the mean? By that I mean less in height than 2 standard deviations below the mean. So in this case, dealing with standard normal distribution, mean, standard deviation, drawing a picture. Shorter than 2 standard deviations below the mean is this section here. So we want the probability of a z-score less than -2 using our graphics calculator. Now we put in the lower bound, the smallest number that the graphics calculator can hold, which is -e⁻99. The upper bound in this case is -2. Standard deviation 1, mean of 0. Probability is 0.02. The probability of a student being less or shorter than 2 standard deviations below the mean is 0.0228 rounded off to 3 significant figures. That means the percentage of students less than 2 standard deviations below the mean, shorter than 2 standard deviations below the mean, is 2.28. So we need to find 2.28% of 1200. 2.28% of 1200 is 2.28 over 100 times by 1200. Other ways of calculating that, but that's the way I like. And if you do that on the calculator, you find it's 27.36 students, or rounded off, about 27 students would be shorter than 2 standard deviations below the mean.